Dear students, the continuation of double and triple integrals. Now I shall discuss on the double integral evaluation by changing the order of integration. Here, by changing the order of integration means why this is necessary for after studying certain problems in the general form like limits as constants, limits as variables. Changing the order of integration needs sometimes the integrals are directly which are given in the particular order may not be possible or may be possible with too much of complication. In such cases, we change the order of integration and then we will evaluate, but while changing the order of integration, it is not a casual change, that is the order like here it is dy dx is there. You cannot write simply this whole integral like it is equal to the same value and dx here and then dy here, but you have to draw the rough sketch of what is the figure for this and what is the figure for this. The intersected part you have to show by the shaded area between these two curves which form the intersection, and you have to define by taking a small strip in that intersected part and then move horizontally and move vertically. Any one of those two cases, but you have to fix what is the maximum length and minimum length of that particular strip which you are moving from the first point to the last point. If it is horizontally moving, then it is certain that x axis will act as or x values will act as variable limits and y limits will be held fixed. This is the basic meaning of change order of integration. For example, if you choose a strip which is moving vertically, that means from the baseline, that is x axis, towards the y axis. When you vary like that from top to bottom, that clearly indicates y has variable limits and x has constant limits. Therefore, sometimes this integration may not be possible as it is with a given order, like for example this dy dx. Here this is a problem which allows both the cases, but you have to explain why this particular problem is or particular case is to be taken, like by changing the limits and by plotting the curve. For example, this is one equation. If I think about another equation, 0 to 4a and x square by 4a 2 root of ax. This is the next situation. In this problem, we take the intersection of two curves, but both are innermost integral curves or standard graphs. They are nothing but parabolas, and the intersection between these two curves we will think of. And next is for example circle if you take, for example ellipse if you take. So, in all these situations, how we are going to change the order of integration, even understanding these few steps, you can extend for any number of cases where constant limits are appeared and variable limits are appeared. So, that how you are going to evaluate these changing the order of integration by changing the limits of the innermost integration and limits of the outermost integration. Let me start with an example how this changing the order of integration goes. Let me start with parabolas, that is intersection between two parabolas, and then I will come back to this special example, because this problem is a special case among the group of problems in the case of a change order of integration. Let me discuss the problem, the intersection between two parabolas, and then I will come back to the integration by changing the order in the case between the curves parabola and straight line. Now, the problem is like this, that is evaluate 0 to 4a and the limits which are given as variable limits x square by 4a and 2 root of ax should be dy and then dx. There are 3-4 commonly we come across the situations. This is one such situation, intersection between parabolas, and next is intersection between parabola and straight line, and the area of the first quadrant in ellipse, and area that is of the first quadrant in circle, even parabolas other types also. Now, as a first step you can indicate, first step to make it very clear, let I is equal to 0 to 4a and x square by 4a, within the brackets you put it 2 root of ax, should be x is there, opposite symbol you have to take, because already I told you in the list of problems when you have solved double integral with limits as constants and double integral with limits as variables. Then here it must be opposite symbol, means dy, and close the bracket, it is dx. Now, for every problem, if you know the rough sketch for the given limits, it is better you draw the rough sketch and see the point of intersection, and then fix from the lower set of limits and to the upper set of limits how the area you are going to vary. Whether according to the given order, first you identify in you have to take a strip and move from which direction to which direction. There are only two options you will find, because there are two coordinates x and y. Either you can move the strip along the x axis, or you can move the strip along the y axis. In all these 2-3 situations, let me explain how this problem behaves. For example, here you plot the curve first. According to this given problem, you have to clearly define this innermost integral, that means y takes function of x and also y takes function of x, y equal to this much and y is equal to this one. That means like y is a function of x lower limit and y is a function of x as upper limit, and this is for x, and x equal to 0 and x equal to 4a, because dx is outermost integral derivative now, and this derivative indicates for the innermost integral. That means these are the variable limits and these are the constant limits. In inequality symbol also you can represent these, both the double integral, even triple integral, even single integral also, by means of inequalities how you are going to represent. For example, this x square by 4a and 2 root of ax, you can indicate like that, x square by 4a less than or equal to y less than or equal to 2 root of ax. This is for variable limits. Therefore, I call these as variable limits. For the by changing the order of integration. By changing the order of integration means you have to be very clear in defining these limits from the given statement itself. You have to accept first which are variable limits and which are constant limits. Now, another outside limits are 0 less than or equal to x less than or equal to 4a. These are constant limits. These are constant limits. Now, when these are the cases, exactly this is the situation for the given problem. But in the case of changing the order of integration, this is a very very important concept. This you have to learn properly. Any situation you may come across as application problem also. Fine. This is first lower limit is x square by 4a. What is the rearrangement of this equation? Rearrangement of this equation, y equal to this one, gives x square is equal to 4ay, and this one so to remove square root sign, squaring on both sides, that gives, this gives like that, this gives y square is equal to 4ax. So, y square is equal to 4ax, otherwise here x square is equal to this one and y here y square. Therefore, x is anyway it is a function of x, means y is a function of x here, and y is equal to x square by 4a. This is y is equal to 2 root of ax. That means x square is equal to 4ay, and if you simplify 2, you can also send it to the other side. So, there are two parabolas. X square by 4a means for y, x square is equal to 4a, where focus lies on x axis, okay, even powers of x. Therefore, you have to plot two parabolas like this. This is for one parabola, and the another parabola also goes like this. This is x and this is y and this is 0, and here it is point which intersects between two parabolas. That is x square is y square is equal to 4ax. This is the parabola, this one, y square is equal to 4ax, and x square is equal to 4ay means this one, because this focus lies on the y axis, but for this parabola focus lies on the x axis. But here we learn how to calculate the area which lies between the intersection of these two curves. This is the area which is to be indicated by means of double integration. Now, what we are going to do here, by changing the order of integration, this order you have to change. Fine. According to the given problem, y varies between these two limits. That means y is a function of x and y is function of x, but x is 0 and x is 4a. It clearly conveys x has constant limits and y has variable limits and x has constant limits. That means this is somewhere, if I take a strip, this problem gives clearly according to the limits. You are taking this strip which is to be moving up and down, because variable limits means y varies between these two. How? It starts from the origin. If it starts from the origin, it will move in this direction, but how it moves means accordingly this parabola takes the shape. This is for y square equal to 4ax and this is for x square is equal to 4ay. So, initially it is 0 like this, and if you continue and if you go on moving like this in the upward direction, somewhere the total length appears and again it will come here as a smaller length. Initially smaller length, increasing and smaller length. So, this is according to the given problem. But what is the length, total length of this strip when you are going to consider? That strip length will be, for example, it is already given x maximum limit is 4a here, and obviously this is a familiar problem. If you substitute 4a in any one of these two equations, either in this or in this one, you are getting the point of intersection 4a comma 4a. That means how that 4a comma 4a lies here like this. This is the total length on the x axis up to 4a, and this is 4a. Therefore, x length and y length. Y length is also 4a, x length is also 4a. But what we are making an attempt here is to find the area which is intersected between two parabolas. Yes, this is the order according to the given problem. Suppose you choose a strip at the top point, then you are moving it downwards, okay, according to the problem. Now, we do not want this system. We want to change the order of integration. Instead of moving instead of moving the strip up and down, I want to move horizontally. I want to move along the x axis. This is the hidden meaning of changing the order of integration. Changing the order of integration means the area is located by means of choosing a small strip either horizontally or vertically. According to the problem, this is vertically up and down it is moving. We do not want this system, we want to interchange. That is the meaning of change the order of integration. That means change the order of integration follows by changing the derivatives as well as changing the moment in showing the application of area. This is basically you have to understand. Fine. What we do for that? We choose a small strip which is parallel to y axis, and this small strip we are moving from origin towards up to the maximum limits, that is 0 to 4a and 0 to 4a. It would have been sufficient 0 to 4a and 0 to 4a, like that. The problem does not require these constant variable limits. It would have been sufficient, but they want the problem to be solved by keeping one set of limits as constants, another set of limits as variables. Let us discuss the solution of this. Let me repeat the case. That means here the total length of this one is between 0 to 4a. Now, if I choose the strip not parallel to x axis and moving up and down, I am taking parallel to y axis and I am moving towards the x axis, positive x axis. That means instead of moving it vertically up and down, we are moving the strip horizontally towards x axis. Fine. What is its length then? Its length also will be 0 to 4a. Therefore, we interchange the limits. Means you have to reverse the values which are assigned. Y is a function of x. You have to write it as x is a function of y in the reverse order. How you have to write in the reverse order means from the same equation you interchange by rearranging the equations, whereas outermost integral limits will not change because both are same. Here from here to here it is 4a and from here to here it is 4a. Whether you keep y for the upper limits, outermost integral limits as lower and upper, or if you keep x for upper and lower limits as constant limits. Therefore, for both it is 0 to 4a. So, what we do here then, upper limits here it is given as y square is equal to 4ax. You have to, it is given in terms of x, now you have to write in terms of y, implies this clearly indicates y is a function of x. Now you have to write x is a function of y. How we can represent x is a function of y? X equal to y square by 4a. This is one interchanging the limit. Another case, lower limit, x square is equal to 4ay. X square is equal to 4ay. This indicates y is a function of x. It was. Now x is a function of y. You are going to write. Okay. X is this one, means here x equal to plus minus, it is 2 root of ay. 2 root of ay, but I choose x equal to only plus sign, plus of 2 root of ay. Why I have taken 2 with plus sign, ignoring minus sign? Because your area lies in the first quadrant. This is first, this is second, this is third, and this is fourth. First quadrant all are positive, so that we ignore this negative sign. Therefore, on changing the order of integration, you can easily write you can easily write that is equal to 0 to 4a, which were for x, now we are going to write for y, and here y equal to x square, that means x square by x square is equal to 4ay gives x equal to this one 2 root of ay, and another one is y by y square by 4a. Now, what is the derivative inside you have to fix? Inside derivative, now earlier this was x, dy was there, now you have to put it dx first, close the bracket, which you have to perform, and then this is y. I hope you understood the necessary steps, because one problem if you understand in depth, I think everything will be automatically you can follow. Yes, this is 0 to 4a, this one in terms of x, now 0 to 4a, this one in terms of y, that is all. Now, let us do the integration here. This is equal to 0 to 4a, dx means x, and over the limits, then 2 root of it is ay, and y square by 4a should be dy, that is 0 to 4a y square by 4a 2 root of a, otherwise a to the power half, and y to the power half. This one if you take, and it must be in terms of y. Now you can integrate. What is that? 1 by 4a, y square means y cube by 3 minus 2 a to the power half and y to the power 3 by 2 divided by 3 by 2. So, this must be running between 0 to 4a. So, wherever y is there, you can substitute the limits and then you can collect the value. What is that value here? That is 1 by 4a here, and y cube means 4a whole cube by 3 minus 2a to the power half and 4a whole to the power 3 by 2 and divided by 3 by 2, and obviously for lower limit both are with variable and limit is 0. So, no term exists. Of course, some simplifications you can do that. This is one situation which we are considering for intersection between two parabolas. Now, I will take another situation, that is another commonly required concept, where slightly different concept in this problem you will notice. Previous problem is straightforward approach, but in this problem some different procedure you have to apply, that means while rearranging the terms. What is that problem says? How that problem behaves? Let us verify. Evaluate 0 to 1 and 0 to 1 x square to 2 minus x, and the function is x y, it is dy dx. Let me briefly give what exactly here different type of rearrangement lies here. You can easily make out. It is a combination of two different curves where the area lies by the intersection is not completely covered by single curve. That is a combination of two different curves. One is parabola and the another one is straight line. This is y equal to x square and this is y is equal to 2 minus x. Okay. If you indicate in the solution, as usual the notation, let I is equal to 0 to 1 and x square, it is 2 minus x, x y, it is dy, close the bracket, and then dx. According to previous problem already we have discussed in detail, this is for y and this is for x. Clearly indicates x square less than or equal to y less than or equal to 2 minus x. This is for variable limits, and this is for x 0 less than or equal to x less than or equal to 1. This is for constant limits. This is for constant limits. Means you can plot the curve and this has to go here and this has to come here. This is called changing the order of integration. The whole drama lies here itself in understanding the problem. When once you understand the problem, it is nothing but solution. Okay. Now let me give the intersected part between the nonlinear curve and linear curve. This is nonlinear because degree is more than 1 and this is linear curve. Okay. What is the plot that you can propose for this? X square is equal to, this is y is equal to x square, that means even powers of x and odd powers of y. Therefore, your parabola should be having the focus on the y axis but not on the x axis. This is your parabola. Fine. And another curve is that is 2 minus x. It will be, if you plot the straight line, it will go like this. This is x, this is 0, origin O, and this is y, and this is y equal to x square, and this is y equal to 2 minus x. Then this parabola will have the focus on the y axis. So this is the shaded part which you are going to work out. This is the shaded part which you are going to calculate as the area lies between the intersection of the parabola having the focus on y axis and the straight line which cuts the positive x axis and positive y axis. Therefore, here what exactly the requirement lies here? From origin to point A. Next, that is B. You have to assign all the coordinates for these points. Without coordinates, we cannot solve the problem. Anyway, origin is obvious, that is 0, 0. Now, here x runs between 0 and 1. X runs between 0 and 1 means here it is fixed. X coordinate is 1 unit. That means here on the x axis this distance is 1 unit. This is 1 unit. Therefore, x coordinate is 1. And y coordinate, here y varies between these two limits, and coincidentally previous problem and this problem will have the same meanings, because in the previous problem also innermost integral was having variable limits for y and constant limits for x, and here also y varies between this one. That means your strip is moving up and down. Now, we do not want this system, we have to move the strip along the x axis. That is the that is the meaning of changing the order of integration. How we have to change? Therefore, if you start with this or if you start with this, total area is connected between, from this if you take along the path of this curve, it comes up to here. So, this is the path of the curve means by parabola, and from this point to this point the path of the curve is straight line. Therefore, it is not the whole length is not described from the first point to the last point until the original point. It is not the combination of a single curve. So, we do not call it as smooth curve. Therefore, what we do, we will discuss the area in a separate two different double integrals. That is the change which I wanted to explain from the previous problem to this problem. For that, what we do here, we drop perpendicular exactly at the center between this point and this point. Here we drop the perpendicular and we will divide. Now, the area is very clearly defined. This area is only with respect to the parabola, it goes on changing, and this area continuously it is changing only with respect from this point onwards, this line onwards. So, this area is connected only with respect to the straight line. Therefore, easily you can discuss this double integral is equal to double integral with respect to parabola plus double integral with respect to straight line. Like this, you have to connect where your area from the first point to the last point and coming back to the original point when it is not connected with respect to single curve, then you have to go for division. Yes. Then when once we write this one, then what are the coordinates at all the points? For example, O, A, B and C here. For all these you have to assign the corresponding coordinates. Corresponding coordinates means you have to calculate those coordinates here, x square by using x square equal to y and y is equal to 2 minus x. What are the coordinates? X square is equal to y is equal to x square and y is equal to 2 minus x. Equate that. X square is equal to 2 minus x. Then otherwise x equal to 0 and x equal to 1. X equal to 0, y becomes 0 and x equal to 1, y is equal to 1. Here one coordinate is directly possible. That means A has the coordinates 1 comma 1. Up to here is 1 and here, that is y is also 1, means C has y coordinate as 1. We have to find out x, and the x is also, that is 1 comma 1. And obviously here how much value you are getting, that means x equal to 0 when you put it and y has the maximum limit. That means at x equal to 0 and y is equal to 2. Therefore, maximum value of y is equal to 2 here, and x value is 0, and here here x value is 0. On the y axis anywhere x value is 0, on the x axis anywhere y value is 0. Here 0 comma 1 and here 0 comma 2 and here 1 comma 1. Now you have to split on changing the order of integration. What exactly the procedure follows? Now on changing the order of integration, it goes like this. To the innermost integral values, limits y is equal to x square implies x equal to plus minus square root of y, but we consider x equal to plus y only, plus square root of y only, because the area lies only in the first quadrant. According to the given problem, y has the variable limits. Therefore, the strip is like this and it is moving like this. But we do not want this system, we want this strip and we want to show that strip is moving along the x axis. This is one value, and the another value is y equal to 2 minus x. So, y is equal to 2 minus x gives x equal to 2 minus y, x equal to 2 minus y. These are maximum limits for a variation of x. Earlier variation of y, but now we have variation of x. These two you can easily make out 2 minus y less than or equal to x less than or equal to root y. So, you can make a connection between this set and this set. These were for y and these are for new limits, that is for x. And now we take this area OAC as one area and CAB as another area. Therefore, you have to split total area into two parts by dropping perpendicular from the point of intersection of these two parabolas, that is 1 comma 1. Now, let me write the new limits which we have to assign after changing the order of integration. What is that order of integration change with new limits? That goes 0 to 1, it is x square 2 minus x, xy, dy, dx, like this. That is equal to area that is OAC plus area CAB. Now, we assign two double integral area OAC with respect to with respect to parabola, and this is with respect to straight line. Now, you have to use your all clear observation here. It starts from 0. Let me write outermost integral lower limit as 0 and ends with 1 because maximum limit is 1. Now, this is for y and this is for x. On changing the order of integration, y will take between 0 and 1 because it is obvious y runs between 0 and 1 here. Then for x means from the origin means obviously it is 0. Then it is for x, and how that x moves in terms of y. X is a function of y along the path of this parabola. Along the path of this parabola means it is y equal to x square, implies x equal to, only I take plus sign, it is root y. Therefore, root y you must write. Then xy, earlier what is the order? Dy dx. Now you have to write dx first and assign dy plus of. Now the integration of this area, integration by means of double integral, this area is completed. Now we are left with this area. From where we have to start? From this point, and we have to move towards this line. By what strip? By taking this strip, and it has to move along the x axis. Along the x axis means what is the lower limit for y? Should be 1 here, should be 1 up to 2. This is for y, and other limits for x. Other limits for x means x is associated with the straight line, x on the y axis as 0, and x for this straight line, this gives y equal to 2 minus x, implies x equal to 2 minus y. This is 2 minus y. Therefore, xy, the order is now according to this you have to write dx and it is dy. This is the very important step. If you do not write this step properly, then it will not carry any meaning at all. You have to explain like this: when the area is not covered between a single curve, that means smooth curve, we have to divide it. So this is one double integral, this is second double integral, and that too on changing the order of integration. It is given as y first and then x. Okay, here also this is for y and this is for x. This is for x and this is for y. X and y are written as y and x. Here also y and x, and y and x means opposite variable, dx dy. If y is there, x is there, x and y is there, but it is an opposite variable. X is a function of y. X is a function of y here also. So you have to perform this simple integration term by term. What is the integration? 0 to 1. Then with respect to x, you have to integrate x square by 2, y, and the limits are 0 to root y, and it is dx, and plus of, it is 1 to 2, and with respect to x, x square y under the limits 0 to 2 minus y, it is dy, dx dy, it is dy. So apply the limits for x is upper limit and x is lower limit. X is upper limit as straight line and lower limit as 0. Let us give the simplification by applying the limits, that is 0 to 1, x is equal to root of y, 2 cancels, then y by 2 into y, lower limit will not exist. This is dy, and plus 1 to 2 plus 1 to 2, x is equal to 2 minus y. So 2 minus y, x square is there, you have to make it as whole square, and y, and lower limit obviously will not exist. This is dy integration. It is y cube by 6 between 0 and 1, and plus of this must be 2 minus y whole square, that should be, it is 4 minus 4y plus y square multiplied by y. After integration, if you take at once, it should be 4 times y square by 2 minus 4 times y cube by 3, and plus of y square into y is y cube, and integration gives us y to the power of 4 by 4. This is between 1 to 2. Then, so you are replacing y is equal to 1 and y is equal to 0. Therefore, 1 by 6 plus 2 times that is 4 by 2 should be 4 minus 4 into 8 by 3 plus 16, 2 square, 4 4s are 16, that is 4, and minus 4 by 2 minus plus it is 4 by 3 plus that is also minus 1 by 4. Now you have to simplify. This answer comes to be 3 by 8. This is a well known answer and also well known problem. So this problem and previous problem, carefully you compare the procedures, both the problems. There the combination was only between the parabola and the whole length starting point till the end point 0 to 4a was connected with a single parabola, but here one straight line and one more is parabola. Therefore, you are supposed to split this double integral into 2 separate double integrals, and then you have to work out. Let me go for this simplification or the analysis of this double integral by changing the order of integration to another few problems. Those problems you can solve, but let me give through different procedure by changing into polar coordinates. What is the purpose behind it? Already I told you that sometimes this problem, already you know that x and y are the Cartesian coordinates. Sometimes the function to be handled under the double integral becomes too complicated. Then if you transfer this Cartesian system into the polar system, then the problem will be reduced to the easier form. Then in such cases, the standard polar transformations, already you are familiar from the complex numbers. You have studied De Moivre's theorem, roots of the complex number. There you must have defined how the Cartesian coordinates are converted into polar coordinates. The standard polar coordinates are, in place of x, x equal to r cos theta and y is equal to r sin theta. Let me solve one situation by changing into polar coordinates from the Cartesian form, how the problem takes the simplification procedure, because directly sometimes the integration performing the integration may not be convenient form. Then we use to solve the double integral, even triple integral by means of cylindrical polar coordinates and spherical polar coordinates. But here, according to the syllabus which is modified recently by naming it as 17 Mat 21, we have to discuss only for the double integral by changing into polar coordinates. Yes, what are the standard polar transformations? X equal to r cos theta and y is equal to r sin theta. That means from the given integral, x and y are Cartesian coordinates. Cartesian coordinates. This implies x is a function of r comma theta and y is a function of r comma theta. From one system to the other system, when you switch over, when you convert, there must be some reason, because casually you can't do that. Why? What we are going to do? For example, then earlier it is in Cartesian form, then function, if it is too complicated and where analytical methods will not support to do the integration, then we need to convert from existing, that is Cartesian system into the polar coordinate system. Yes, let me take one situation and then we will discuss how this problem behaves by introducing polar coordinates. Example to evaluate, both are with maximum limits 0 to infinity and 0 to infinity, e to the power minus x square plus y square, it is dx dy, it is there. This is the problem. Okay, this is only a case where product dx dy multiplied by some function and different functions in different problems will be there. Yes, you introduce these values, at the same time we take the help of Jacobian, which you studied in 17 Mat 11 first semester engineering syllabus. You have studied one concept, that is a determinant of the partial derivatives for the same polar coordinates, x equal to r cos theta and y is equal to r sin theta, that is del x by del y, this is called Jacobian, del r, and del x by del theta, del y by, that is del r, del y by del theta. What is the answer for this? That is J means it is nothing but dx dy divided by dr d theta. This answer is supposed to be r. Therefore, by taking cross multiplication, dx dy r equal to r into dr d theta. The main purpose of Jacobian, which you studied in first year engineering mathematics syllabus, that is first semester, Jacobian values, this is the case of two variables are connected to two variables, then the product of the derivatives can be replaced by this quantity. This is from Cartesian coordinate system and this part is from polar coordinate system. That means you are transferring from Cartesian to the polar system. Yes, why to transfer this, and what is the main purpose behind it? So, this integral probably we may not be able to solve by analytical methods. When once you introduce these values and suddenly this product appears, you cannot do dx separately and dy separately. So, product should be replaced as a product only, that is dx dy is equal to r into dr d theta. How it goes? Let me explain here. So, put x equal to r cos theta and y is equal to r sin theta. This gives, already you know that, in the circle, what is the radius? By making sum of the squares of x and y values, that is x square plus y square is equal to r square. This r will be the radius. X square plus y square is equal to r square. Fine. X square plus y square is equal to r square means from the given integral according to this order, this is for x and this is for y, but both are having the maximum limits. What kind of limits? Like this: 0 less than or equal to x less than or equal to infinity, 0 less than or equal to y less than or equal to infinity. Both are having maximum limits. That means here length of the radius vector, because this is the initial line, length of the radius vector in the anti-clockwise direction, when you rotate like this, it comes to the original position like this, but the length of this radius vector from both the coordinates is maximum. That means 0 to infinity. Now, what is the vectorial angle which we are going to generate by taking the anti-clockwise rotation? The vectorial angle from this is, according to the given integration, 0 to infinity means that lies only in the first quadrant. Only in the first quadrant means vectorial angle we have to restrict theta equal to 0 degree and theta is equal to, it is 90 degree. So, 0 to pi by 2, because you have to give the variations for r for dr and variations for theta. What is lower limit and what is upper limit for theta as well as r? So, theta runs between 0 to pi by 2 and r runs between 0 to infinity. Therefore, when you this product dx dy should be replaced by r into dr d theta. From where you got it? This product you got it from Jacobian. Therefore, we consider this as 0 to infinity and 0 to infinity e to the power minus x square plus y square dx dy is equal to, should be 0 to infinity, that is with respect to r, length of the radius vector, and 0 to pi by 2, then e to the power x square plus y square is equal to r square and followed by minus sign as it is, we are not disturbed it, and r into it is dr and then d theta, r into dr d theta. That means, this double integral clearly conveys you have to perform the integration first with respect to r, treating theta as constant, and next with respect to theta treating this r as constant. Okay. You can restrict or you can indicate theta for 0 to pi by 2 and r length of the radius vector between these two. So, you have to perform this integration for innermost integration first, then outermost integration. Till here, now I will give a break. If you have any questions, then I will answer it. You can ask.